Alright, November the 5th. Alright, let's go for it. Seat reservation manager. Design a system. Reservation manager. Design a system that manages the reservation state of n seats, a number from 1 to n. Complement the class. Seat man initialize it. Manage n seats, number from 1 to n. All seats are initially available. Reserve fetches the smallest numbered unreserved seat. Reserve it and it returns its number. Have I done this before? Looks awfully familiar. Reserve the smallest numbered unreserved seat. Reserve it and it returns its number. Unreserve the seat with a given seat number. So basically have n seats, and if you want to reserve, you always reserve the smallest numbered unreserved seat. And you unreserve, that one gets back, which means all we need is a priority queue, right? Priority queue will hold all the unreserved seats. And every time you reserve, you pop the front and you put it in. Doesn't matter. What if you unreserve, you have to pass a value, right? What if this one, for each reserve, it is guaranteed that there will be at least one unreserved seat, which call to unreserved guarantee that seat number will be unreserved. Which means every time you call unreserved, you just put it back, right? That's basically it. Yeah, you call reserve, and you call reserve. Unreserved 2, you put 2 back. Yeah, I think priority queue will work. Yeah, this is not, if it is what I think it is, it's not really that difficult. All we need to do is to, just provide, we say this dot seats, unreserved seats, right, equal to, actually no, priority queue integer unreserved seats equal to new priority queue. Okay, so what we do here is to say for int I equal to 1, I smaller equal to n, I plus plus, unreserved seat dot add I. Okay, that's that. And the reserve will just return unreserved seat dot poll. Well, we have to do if unreserved seat dot is empty. Hey, is this throw? Error. We have to say no unreserved seat. Actually, no. Probably have to say new. That's interesting. I never know how to throw error. Oh wait, hold a second. I think this is right. Okay. And this one we just do unreserved dot add seat number. I think this shall do. Yeah, I think it should do. Nah, I've never done this before. We have an if check, so maybe if I don't do this, right? Which also means we can do this with here. Use priority queue. Actually, I'm not sure. How fast would this be if I remove the other one? Yeah, that's about right. The if call costs some time. Six. Okay. Main heap. Without pre-initialization. Ooh, that's interesting. So every time you will... Oh, without initialization. So when you start, you what? Maybe we can try this without initialization. So what I think we will do, so we don't do anything. Okay, don't do anything here. We need to say what? The current, right? Current. Say int. Current will be 1. Okay, so if we want to reserve, we say if current, if un is empty or current is smaller than unreserved dot peak, then we return current. Well, wait, which one's which? Yeah, I think it's current plus plus, right? So you return the current and then you will plus afterwards. Otherwise, and once the current gets to really big, current always go big, right? Otherwise, we shall return unreserved state dot pull. And here, unreserved, we always put it back. So this kind of is, you know, let me see. Does it work? Yeah, I think it works. So this is without pre-initialization of the unreserved mean heap. We just use this to keep track of where we are. And every time we unreserved, we always put it back into the priority queue. Otherwise, we keep incrementing that. I think this might be a little bit faster. Oh my god, it's a lot faster. It is a lot faster. I did not even think about this. So, yeah, it's interesting. Marker. Yeah. Yeah, the red black tree, AVL tree. Tree set. Interesting. A tree set. Sorted set. Python will be using the sorted set. And make sure that there's only one, right? Dot first. Remove add. Interesting. Okay, so that's that. All right, let's do this one. Find the longest semi-repetitive substring. You're given a zero-indexed substring and a dat consists of digits from 0 to 9. A string T is called a semi-repetitive if there is at most one consecutive pair of the same digits T. At most one consecutive pair of the same digit inside T. For example, this, and this are semi-repetitive. At most one, so you can either have one or you don't have one. And these two are not, because this one has 2. This one has 2. Return the length of the longest semi-repetitive substring inside. Interesting. 4. Yep, 5, 2 to 3. The whole thing. That's only 2. Very interesting. Given S length as this, my goodness, what's the DP gonna look like? All right, so we have a string. We have an example 5, 2, 2, 3, 3, right? So we want to find the longest semi-repetitive. So it will end as something. So we can say, if I know the longest semi-repetitive ending at everything, okay. Now I'm looking at this one. Okay, we want a semi-repetitive, right? So semi-repetitive, it could be maybe I need 2 things. The semi-repetitive and the no repetitive. The longest no repetitive. So long as no repetitive, so we have no repetitive and a semi-repetitive. Because what I'm thinking is, if you add a current one, if the previous one is not the same, then your longest semi-repetitive is the same as the previous semi-repetitive plus 1, right? Because that's just the case. And if these two are the same, okay, then your semi-repetitive will be the non-repetitive of this one, right? That will be your case. So no repetitive will be 1. No repetitive of this will be 2, because previous non-repetitive. Ooh, how would you know, right? How would you know? So you need to know the index of 2. It never occurred before, and it's 2. So you know the index, the previous index of 2, right? And then you can only get in between. So this is 1, right? 3. Hold a second. No repeat, right? No repeat has to be the no repeat in the previous. Yes, no repeat of previous. So this has to be 2. No repeat of previous. And no repeat of previous, but oh, hold on. There's 2 things. No repeat of previous, definitely. And then you also need to check. Yeah. So we have the first check. Check 2 things. No repeat of previous and your repeats. So if your repeats happens within the no repeat previous, then you have to get them smaller. Otherwise you get the no repeat previous. And here, again, no repeat previous is 2, but this is a repeat. You have a 3, right? And it will also always record the largest. And then so this one is 1. So this is a no repeat. Now we can do semi-repeat. So the first one, semi-repeat, is always 1, right? And then this one, it's always the previous semi-repeat plus 1, okay? This could be, no, this is the same. So it's gonna be the same, the previous one, the no repeat, right? So this will be 3. This, the previous no repeat, a semi-repeat plus 1. This one, 1. So this will be 3. So the answer is 4, right? So we can do another one, 4, 5, 9, right? So we have a no repeat and a semi-repeat, okay? So no repeat is 1. This is a 1. This is 2. This is 3. This we check. This is 3. Okay, and then so basically when this is 3, it's the previous, right? Previous, and then we check this. This is 2. This is 0, 1, 2, 3. 3 minus 2 is 1. So we have 1. So we have to take the smaller one. So this is only 2. Semi-repeat, this is 1. This is a previous one plus 1. This will be the previous one plus 1. This will be the previous one, right? Because it's not the same. Oh, what if this one has a repeat? Oh yeah, it could be, right? So, holy crap. Oh, but it's just a consecutive, right? It's a consecutive pair, so it doesn't matter. It's the consecutive pair. It doesn't matter. So if it's a consecutive pair, you always do this plus 1. And if you are, then you cannot have consecutive pair. Yeah, you just don't have consecutive. I don't even need this. It's not consecutive pair. So you can have repeats. It doesn't matter. All you want is no consecutive pair. All you want is no consecutive pair, right? That's what a semi-repetitive means, is at most one consecutive pair, right? So if your current and your previous, if these two are not the same, then it's definitely the previous plus 1. Now, if your current is equal to pre, now this is interesting, right? Your current is equal to pre. So now we have a consecutive pair. So we want is the previous one from this, right? That does not have consecutive pair, but it can have repeats, right? Like 1, 0, 1. This is good, right? 1, 0, 1, 2, 2 is good, right? You just double check on this. Just double check on this. This is good. If we do 1, 0, 1, 2, 2, this is good. This should be 5, right? This should be 5. But in your previous idea, it's going to be wrong. Yeah, this is good, which means we need to find out a semi that without a consecutive pair. Ha! How do you know that? Consecutive pair. Maybe we should find out all the consecutive pair beforehand. What do you think that? All the consecutive pairs. So we don't even need to care who they are, right? We just find out all the consecutive pairs. And of course, if there's only one consecutive pair, and then that's it, right? So basically, we'll know, A1, A2 is a consecutive pair, right? B1, B2 is a consecutive pair, C1, C2, and all the way, right? So among the string, we have like this is a consecutive pair, this is a consecutive pair, this is a consecutive pair. And we say, right, we want the longest, which means no two shall exist in the same, right? Which means our answer will be either this, right? This substring, right? Or we say we're including this. Oh, holy crap. No, we shall include this entire thing, right? That is or and here we'll include this. So we'll have, let's say, a array. Okay, we have array of indices. So left and a right, left and a right, left and a right going on. And then the answer will be this, and everybody in between will be from here all the way to this. Right, from here all the way to this. So what we need is indices, right? We have indice here, I, and then we'll have to jump 2, right? I plus 2, and then we calculate this, move forward, right? Move forward, so it will be here to the next one, right? So if we have another one, it's going to be starting from this all the way to this. And then we include the front and the end. So if we use this idea, 52233 will be converted into 0, 1, 2, and 3, 4. Right? It's less than 3, so we have to take 2 plus 1 equal to 3, or oh, that's not right. That's not right. You can take this. Holy crap. So we might need, yeah, we need something on the outside. We need something because, yeah, I just realized, because you have this, this, this. The first does not end here. The first ends here. Right? The second is from this to this. And the third is from this to this. Which means, so here, the way we calculate it will be, you know, I want a consistent, okay? I want a consistent way to find the answer. So we shall do the front, right, minus the end plus 1. So in this case, shall be 3 minus, maybe we can put a 0, 0 at the front. Okay, so it'll be 3 minus a 0 plus 1. That's the first. And at the end, we put another one. Let's say 0, 1, 2, 3, 4. Maybe we say 4 and 4 is at the end, right? So we'll always do the 3 minus 0, and that will be 4 minus 2, right? 4 minus 2 plus 1, so it'll be 3. So we say either we do this, or we do this. Yeah. So in this case, we have nothing. If there's nothing, just the entire thing. Right? If we only have 1. So we always do 0, 0, and, you know, n minus 1, n minus 1. Right? So if it's nothing, then we just return a full thing. If we have only 1, we return a full thing, right? If we have 2, then we compare, we do this. Okay. Well, how about this? This will have multiple, right? This basically, we have 0, 1, 1, 2, 2, 3, 3, 4, da 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 da, right? And we have a 0, 0 at the front, and now we have whatever at the end. So we just do, you know, we start from this, 9 plus 2, we do 1 minus 0 plus 1, right? Next one, 2 minus 1 plus 1, so always going to be 2. Okay. That will be my solution, which I think is very optimized. All right, so what you're gonna do is we need an array list. I would call it list of int. Okay, what do we call this? Indices, new array list. Okay, and then indices dot add. We always add new int. Okay, 0, 0 at the front. And for int I equal to 0, I smaller than s dot length minus 1. Okay, I plus plus. If s dot char at I plus 1 is equal to s dot char at I, then we say indices dot add new int I and I plus 1 all the way to the end. If indices dot length size smaller or equal to 3, oh, hold on, indices dot add new int s dot length minus 1, s dot length minus 1. All right, so if it's smaller or equal to 3, which means if only one pair of consecutive or no pair of consecutives, then we just return s dot length. Otherwise, we say int res equal to 0. Okay, so we want the largest. And for int I equal to 0, I plus 2, right, smaller than indices dot length size. Okay, I plus plus. Then we say res shall equal to math dot maximum res indices I plus 2 0 minus dot get I plus 2 0 minus indices dot get I 1 plus 1. And when this is done, we ought to return res. Okay, so that is my answer. Let's take a look. Is that right? Looks all right. Let's give it a shot. Yep, not too bad, but the runtime is really bad. The runtime is really bad. Let's improve it. So first of all, we don't need all this. We just need int pp pre, right? Go to new int 0, 0. Okay, and so we have a previous, and we have a previous. Okay, so as we go through, so what I want to do is not to create this array list. So I have a pp, and I don't even need both, if you think about it. I just need one, right? Every time I do it, right? Every time I do it, the current one, I, basically using this to minus that, right? This to minus that. But how am I supposed to? You always go to the end, right? You always go to the end. So you always have the last one, okay? The last one minus, okay, that's fair, that's fair. So if we only have only one, this will, do some stuff. But how do I make sure we don't update the current to that? Oh, we can count. Yeah, we can have a PP, and then we can have a. We can have. Yeah, we can have. We need to have two, right? So, for one thing, it's just a P. PP, right, equal to 0. We say int P is also equal to 0, right? And now we say for this, that's fine if this is equal to that, and we also have int res equal to 0, right? If we have the same, so what we will do is to use, we'll say res equal to mass.max res, and we'll use an I to minus pp plus 1, okay? And after we've done that, right, after we've done that, we have to update. So we say, pp will equal to p, right? pp will equal to p because we move forward, and p will equal to I plus 1. That is interesting, right? So we move both forward, and then when we move forward, it's always on the right hand side, right? It's the right double. Yeah. And then we'll go to the next one, and then we handle it again, and at the end, we have to do one more check. We can say res equal to mass.max res. So at the end, it's going to be s.length minus 1 minus pp plus 1 at the end. Okay, so when we're done, then we return res. All right, let's check this one. Let's see how this one goes. This one looks better because it has O1 extra space and a void with no, okay, so O1 extra space. Let's see. Yes, faster. I think this one doesn't have any more to say about this one. It's pretty standard. Interesting. IJ last. Same idea, right? The same idea. Okay, well, we're done with this one. Move on to the next. I'll leave it here, and we'll call it today. All right, now see you guys tomorrow. Adios.